Welcome to another in Keysoft's webinar series on how Keysoft LandCAD helps landscape architects and designers have more time for thoughtful design and improves profits for the firms they work for. I'm Ken Deese and I lead marketing in North America here at Keysoft, and Nate Qualls is going to be your webinar speaker. Nate is our product lead here at Keysoft. So what we're going to do today is, again, demonstrate how Keyscape LandCAD is helping firms of all sizes be more productive, efficient, profitable. And in this session, Nate's going to focus on ground modeling and site analysis built specifically for landscape architects' needs, eliminating the design and documentation steps, vastly improving plant and hardscape takeoffs, easy integration with civil engineers and architects. So let me turn it over to Nate.
Thanks, Ken. Let me get to the next slide here, and I'll go over today's bullet points. So today we're talking about surface modeling, site analysis, those kind of 3D tools that are part of the Keyscape LandCAD suite. I just want to emphasize for those new to the product that this is really just one module of the suite. There's other modules such as planting design, paving, irrigation, and these really all tie together into one holistic solution for landscape architects. So first off, I'd like to talk about our surface modeling solution, how it compares to the other offerings in the market, and kind of highlight the pros and cons of each approach. Then I'd like to talk a little bit about how we can help bring together the different members of your design team, whether that be a surveyor or a civil engineer or an architect, and how we can help that interoperability between players using various drafting systems, different file types, and such. Then we'll get into how we can help streamline the upfront modeling of existing conditions, how to analyze the site, the physical attributes of the site, and then how we can help address modeling proposed conditions, calculating cut fill, getting that quantification that can really back up your design early in the design process where changes are easier to make and cheaper to make. So topic one, let's look at what's out there. So Keyscape LandCAD, we chose to piggyback on the AutoCAD platform, and that's because there's just tons of pros of doing that. A lot of people use AutoCAD. There's a big pool of designers we can pull from when we're hiring new landscape architects. It works well with a lot of other products, such as civil engineers using Civil 3D, or even some Revit compatibility, which is something we extend with Keyscape LandCAD. And then other third-party softwares like SketchUp and Rhino, all can speak that DWG language. The cons of AutoCAD have always been that there's no tool specific for landscape architecture, and this includes the Civil 3D suite, which has some overlap with our offering, but is definitely overkill for the landscape architect's scope of work. It's not very intuitive, and it's very costly. And again, there's some data exchange between the AutoCAD platforms, but not complete exchange. And that's where we come in again, is to help with that exchange, whether you're going to Revit or whether you're working with civil engineers using another design platform. Other things in the market that a lot of us use on a day-to-day basis can achieve some of the same results, but there are usually limitations with most of these. SketchUp is great, it's quick and dirty, and it's very conceptual, but it lacks that connection back to the DWG format for your construction docs. You don't have that defendable, accurate model. So there's a lot of back and forth if you're using SketchUp for surface modeling. Rhino's become more popular. It is a very powerful modeler in that it uses a NURBS style, if you're familiar with that nomenclature. But again, it lacks that connection back to your construction documents, back to your kind of one source of truth, your base plans and the AutoCAD platform that most of us work in. Some folks look at Revit. Revit's really designed for architects. There are some surface modeling capabilities, but they're very approximate, and they're more for just providing the architect with a ground plane to sink their building into. 3D Studio Max is very powerful. It's used by animators. It's used, big budget movies use this capability. It's very powerful, but very overkill and very hard to learn, especially if you're a landscape architect and 3D modeling is not your profession. It's just something you need to do on the side. And last of all, Lumion. It uses a video game style rendering engine. Again, it's quick and dirty. It's great for architecture. There are some landscape applications for it, but again, it lacks that connection, that defendable, quantifiable calculation of your design. So why look for Keyscape when you need surface modeling done? It's because we're designed specifically for a landscape architect. We've laid it out in a what we think is more intuitive approach. It's a site-based approach rather than, say, Civil 3D is a more of an alignment or corridor-based approach for roadways and piping. It integrates with the rest of our capabilities, including plant design. If you have a 3D surface in your drawing, we can automatically snap our plant material to that surface, and wherever that plant material might move, it will adjust the Z value and place it correctly in the Z elevation. And it enables you to have this one source of truth throughout the phases of your project. As you go from concept to design development to construction documentation, you can use the same suite of tools that enable quick revisions, quick quantifications of whether it's cut fill, whether it's plant counts, whether it's paving area, whatever it might be. But it's that one source of truth that we try to we kind of harp on a bit. It's very accurate, cut and fill, down to the 10th of a cubic meter, and direct interaction with your DWG formatted construction drawings that you're going to be issuing at the end of the process. So let's look at sharing and how we get this process kicked off. Where do we start? It depends on kind of what phase of the project that we're brought in as landscape architects. Maybe we're starting from scratch. We're bringing in public data sets from USGS or digital elevation models. We're bringing in point data from those. Maybe the drone surveying is becoming more and more prevalent with firms we've spoken to. We can take in those point files, whether they're actual AutoCAD DWGs or if they're just plain text files. We can bring those in as point clouds. If you've already contracted a surveyor, or if your clients already contracted a surveyor, we can bring in their GPS points if they would provide it to you, or if their survey is done in 3D with points, contours, any kind of feature line that's that has a Z elevation we can use. And finally, the land XML format is very underused, but it's very powerful. And this is a way you can exchange surface data information between different suites. So like Keyscape could send a land XML file to your civil engineer using Civil 3D, or maybe they're using a Bentley product or something else, but land XML is pretty universal. So they could take your surface, quantify it, adjust it, tweak it to their design needs, send it back to you, and you can see those results and maintain that integrity of the surface back and forth. So let's take a look at a bit of a demo now and kind of see how the product starts working, give you a framework of how we approach things. So I've already created this, a blank surface called existing. I've got these points that I've imported from a text file. I've got a site boundary that I've got from a surveyor, or maybe I've taken it from a parcel map or something like that. And what I'm doing is assigning all those points to my surface model. I'm saying to cut that surface model at the boundary and to triangulate that, and there it has. You can see it's in the 2D wireframe view. It's not much to look at, but it's there, and now we can start understanding the site better. Here, I'll flip into a 3D view, make it a little bit easier to see what I'm doing in all dimensions. based on those points in that surface, I'm going to go ahead and illustrate it using contours. I like doing that just because it's easier for me to understand. I've worked with contours enough that they're intuitive to me. Plus, it makes things pop a little better when we're in a 3D view. So we're just going to rotate those around. We created those contours, on the layer we wanted with the interval we wanted. So whether you're in metric or you're in feet and inches, you can make those intervals as you see fit based on the steepness or the shallowness of your site. And now I'm just querying the surface model for some spot elevation, so I can get a sense of where the drive into my site might need to be located in the Z elevation, or just get a range, get a feel for the site. It's going to come more into play when we start trying to fit building footprints into the site and start developing a proposed condition. And then now, before I'll get into in more detail in the next section, but I'm going to go ahead and do a slope analysis here. I'm going to do another triangulated surface, but instead of being just this green color, it's going to be all different colors based on slope ranges that I've defined myself. It did that, it calculated it, it spits out a table for you, which looks like I kind of place it overlapping some the triangle, but that's okay. So you can really quickly, within 5 or 10 minutes, see what portion of your site is developable, what the cost implications might be to your client, and be able to make some responsible design decisions and recommendations within minutes of getting the project, or even before you win the project at the proposal phase. Get a deeper understanding before you even submit your proposal. So there I've turned off the contours to make it a little bit easier to see. We have a pretty big developable pod in the middle of the site there. You can see we might have some challenges here. We have a stream corridor that we probably want to avoid anyway, but we can see the red down there. And then up near the road we had some as well. It's going to be a challenge for gaining access to the site as well. There on where I'm zooming in here now. But that's a great start. I did all of this within just a few minutes, and now we can dive a little deeper into how we're going to further understand this site, identify opportunities and constraints. I always like to throw this slide into our presentations. It's a little abstract, but this is the mindset we have when we're designing features and new features, new functionality for Keyscape. Is we want to shift the effort and the effort curve to the left. The orange represents the traditional design process where you design, it kind of builds up over time, and then the effort really spikes during the documentation phase. We'd rather get a lot of that work done up front, and we enable that by letting computers do what computers do well, which is count things like plants, quantify things like cut and fill, just to take some of that production process off of the human workload and put it on the computers, giving us more time for thoughtful design earlier in the process when design changes are cheap and don't affect our client's budget as much. Here's an example of some of the other outputs we can have: slope, elevation, aspect, drainage analysis. Within a half an hour you can have all these cranked out. So here we're back in the program. I've rendered this site analysis a little bit differently in this demonstration. I've used a grid, which it's the same end result. It's just instead of using the triangulated surface, I've overlaid a 20 by 20 grid. You can specify whatever size grid you want for the level of detail you need for your site. And of course, the performance of your workstations are going to affect kind of your decisions here as well. Once you get into 3D modeling, system requirements do go up. But I'm just running this on a laptop right now, nothing special. So it's fully capable on almost any machine. So here I've isolated my buildable slopes and just highlighted the ones that are a little more challenging, so I can start to site a building pad, or maybe this is a parking lot, or any kind of big flat surface, just for some early study here. So I've created that. I'm going to zoom in and draw a rectangle. It's going to represent my building footprint for now. I'm going to arrange that approximately where I want it on site. And right now you can see on the right it's just at 0 elevation. So I want to maintain, I don't want to project this to our existing yet, because I want this surface to be flat. So what I need to know is what elevation should this footprint be at. And to get that information, I'm going to query the existing surface again. So here I'm going to place spot elevations, select my existing surface, pick a point. It's going to analyze that and spit out the exact elevation based on my triangulated surface. Even though it's not on the screen right now, it's not even in this drawing, but as a triangulated surface, it's just in there as an invisible surface. It's still going to query that. Now I can make a decision about what elevation to place my building footprint on. So let's pick 936, and there the polyline jumped up to that location. And let's run with that and see what it looks like when we start tying this into the existing terrain. So I'm going to turn off some of those distracting layers. I'm going to project the slopes from the edge of my polyline down to the existing terrain. And I'm going to set that at, right now, just 15% as, say, just get a feel of what it's going to take to site this rectangle. I'm going to select the boundary, and the side, outside the boundary is the direction I want to go. And there it's found at that delineated slope what it's going to take to meet grade. The magenta line map represents that match line, that limit of cut and fill. If we rotate around, you can kind of see how we're filling downhill and cutting uphill. And these are really just constructed as feature lines, so they're all polylines with 3D information. And when I'm ready to make this its own surface, I just isolate those objects, create a new surface. So I have existing, now I'm going to have a proposed. And normally in a larger project, you're going to have several proposed, because you're going to be working with different components, paths, roadways, buildings. You can have up to I think 99 surfaces in the current iteration of Keyscape. And those can all be manipulated, joined, merged, cut from each other, added together. So it's an iterative process. It's not something you're going to knock out on day one, but as you develop your design, get more information, more feedback from the client, and refine and work, you're going to work towards that more complex proposed condition. So I'm just setting up the layers here so that this proposed surface goes on a new layer called P1. And now let's place the triangles on this surface so that we can visualize it. And there it is. Now that that's built as a surface, we can start understanding more about the site, see if we made a good decision on our finished floor elevation we picked, see the impact. As you'll see on a later demonstration, sometimes you can't meet grade at a feasible slope, and so at that point we'll have to start working with vertical walls or retaining walls, and we'll touch on a little bit about how we model those as well. Let's go ahead and generate some contours for this proposed surface. There they are in red and yellow, and you can see how they join in to the existing contours that are in the shades of gray underneath. So at this point, we've already talked a bit about it, but let's go a little deeper into working with your proposed condition and getting cut and fill calculations. So these 4 images here are just a nutshell of how you go about that. We have in the upper left a existing terrain. On the upper right, we've punched in some building foundations into that, along with some other rough grading information for some pathways and some roadways. In the lower left, I've overlaid both of those so you can really easily see, where we're cutting, where we're filling. We have the software automatically calculate those volumes for us. And if that's acceptable, we've reached kind of a balanced, acceptable rough grading plan. We might move on to something else like rendering some 3D views with some trees and progressing down the design development path. So here, this is the same site I was using, but I've jumped forward where I've got a more complex building mass. I've got a kind of a skirt around that building that drains water away from the building at about 2 or 3%. And then from there, I've projected my slopes down to the existing terrain. On one side, the north side of the building, we weren't able to meet slope without going outside of the property line, so we did a retaining wall over there. Here you can very easily see where we're cutting and filling, but I want to quantify that and see where we really stand. So I'm going to compare the existing condition to P1. It's going to analyze that and give me a report here. And we can see that our cut's about 42,000 and our fill's about 44,000. We're not too far off. We can also factor in compaction factors if we want to get that to that level of detail. And I can also place the report in my drawing. So we've done a pretty good job of citing this. Let's isolate some layers here so we can better visualize what's going on. And let's generate our contours for this proposed surface again. Again, it makes it a little bit easier to see. Here we can have unique layer names so we can have multiple options in one drawing. It's going to erase the existing contours and replace those with the new ones based on our new projections and our new retaining wall. Let's turn off a few more objects. And let's turn off our building mass. So we did consider a excavation for the foundation there, because that's going to really factor into the cut and fill of this site. And we did that, as many of you know, rendering vertical surfaces is a challenge for most programs, and the way we get around that is by offsetting slightly, giving a slight batter to those vertical surfaces. Even if it's just a few inches of offset, that's all it needs to be able to render that. And so say we're happy with this, we're kind of moving forward into the construction document phase. We can do things like automatically annotate contours. Really simple things. They're not going to change the world, but they really speed up the construction documentation process. And it's all these little things that add together that help add efficiency, increase profitability of your projects, decrease your chances of mistake as you're pushing forward. So let's freeze off a few more layers, and let's start placing some trees. So maybe let's pretend we jump forward into our landscape design. And this is early in the process. We're just working on some tree massing. This is kind of where the interoperability between our modules comes together. We're going to place some trees on the slope. I'm just have these trees represented with a 2D symbol, just a simple tree symbol, using SoftWorks, our plant design module. And we can see that they're assigned to the correct elevation. They're kind of hidden. They're half inside of the surface or half on top of the surface. If we render these using a 3D symbol as instead, which we can do dynamically on the fly because Keyscape knows that these are trees, that these trees have a certain size, and we can swap in any block we want to, whether it's 2D or 3D, and have it represented to the correct scale. So there we swapped in a 3D symbol, and we can move these around, adjust them as needed in 2D, and automatically in 3D they're going to adjust to the surface. So you don't have to worry about that. This is a really good way to set up for a rendering. Maybe you use some post-processing utilities to get a more hand-drawn feel or more photorealistic feel if you're not comfortable rendering in the AutoCAD environment. AutoCAD is very powerful with its built-in 3D rendering tools, but we leave it open to you to decide how to best use those tools. So a few takeaways to what I've gone through today. You have options for terrain modeling, but Keyscape LandCAD is the only one specifically tailored for landscape architects' needs and ties in to other modules that relate exactly to their scope of work. We enable you to share data and collaborate more easily with your partners through LandXML, through some export to Revit utilities we have, and other BIM utilities that are built in to Keyscape. We enable you to shift that effort curve forward in the process, understanding quickly your physical site requirements and design decisions based on those. You can revise and quantify those conditions early in the process as well, get a handle on costs for your client earlier. And having one core software solution, one source of truth for your design as it moves through the phases adds a lot of efficiency and potential for increased profit across the whole project. With that, guys, thanks for joining. I'm going to hand it back over to Ken for some final thoughts.
Thank you, Nate, and thanks to you, everyone, for attending our webinar today. We hope you have a better idea of how Keyscape LandCAD can help designers have more time for thoughtful design and help the firms that they work for capture more profits through greater productivity. If you'd like more information on Keysoft LandCAD, you can reach us at these numbers. Contact Mike Schuman at 617-933-9822. On his cell at 781-603-8258, or contact him via email at mike.schuman@keysoftsolutions.com. Thank you very much, everyone.